Okay, good morning everybody. It is the 12th. It is 1/12/21. Look at that. 211, 221. Anyway, silly. So here is a little bit of what the test is going to look like tomorrow. So we're going to have a little bit of right triangle trig as well as a lot of law sines, law cosines. So first of all, if we take a look at number 1, it says all 6 standard trig ratios. So ratio is a fancy word for fraction, okay? So if you don't have these in your notes, all right, got right triangle trig, sine over cosine, sine, cosine, tangent, cosecant, secant, cotangent. What we need to do is make those ratios. So here's my angle, the 3 is my opposite, the 4 is my adjacent, and the 5 is my hypotenuse. Hopefully you guys can understand that, because here's my angle directly opposite the triangular lake, because 5 is the hypotenuse and the adjacent. So all I'm going to do is sine, which is going to be the opposite, or the hypotenuse, just going to be 3/5. That's my answer. Cosine, which is the adjacent of hypotenuse, which is going to simply be 4/5. That's my answer. Enough. And then, of course, tangent is opposite over adjacent, so it's going to be my 3/4. And that's a fraction. Of course, now the cofunctions are just the reciprocals. So the reciprocal of sine is cosecant, so 5/3. Secant, the reciprocal of cosine is 5/4. That's it. And cotangent, the reciprocal is 4/3. That's it. Okay, that's all you have to do. Easy. Okay, now number 3, we're going to actually have to do some work. So here's the key. Law sines, pair of opposites. If it doesn't have a pair of opposites, law cosines. Okay, so right off the bat, it has a pair of opposites. It really does. So here's my opposites. Okay, and what I notice right off the bat is I can find angle C. Okay, call that theta. So I can use my law sines to find an angle. I'm going to set up this one right here. So I'm going to go sine of theta over 19 equals sine of 44 over 15. Sine of an angle over top of side equals sine of an angle over top of side. Then I'll multiply by the 19. Okay, I'll use my calculator, and I'm just going to skip some steps because it's the review. I want you guys to do actually 19 times the sine of 44. I'm going to divide that by 15. But of course, look for the answer. I'm looking for an angle, so I have to take the sine inverse of that, right? Of that answer, and I will. Okay, so I'm doing a second sine of that answer, and I get an answer of about 61.6 degrees. Okay, then find an angle B is easy from 180 degrees. But then if you want to find this side, well, let's just do that really quickly. 180 minus parentheses. Didn't want to do all of it, but I'll do this one. Plus 44. Okay, I get a 74.4. So if I want to find this side here, call it little b, I'll go little b over the sine of 74.4 equals 15 over the sine of 44. Multiply this up there. 15 sine of 74.4. Close the parentheses. Divided by sine of 44. And I get an answer of about 20.8. So now, then the area. Find the area. I have a formula for area. I do. Area formula is 1/2 adjacent times adjacent. So let me slide this down. So this is my angle. There's my adjacent. There's my other adjacent. So I can go, okay, 1/2 my adjacent, which is 19, times my other adjacent, which is 20.8, times the sine, because that's the formula, of theta, which is 44 degrees. And I'll let you guys figure out what that is. Okay. Number 5 is very similar to law sines. Oh, no, it's not. Oh, number 5, it's got to be law cosines. There's no opposites. No opposites at all. Okay? There's no opposites. So what I'm going to do is this. Number 5, there's no opposites, so I use a lot of cosines. So I know side, side, side on this one. I know side, 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 so I want to use the law of cosines. So pick any angle, doesn't really matter. How about if I pick x? All right. If I pick angle x to solve for, I'm going to use this one. So I'm going to go cosine of angle x is equal to, okay, so if it's angle x, that's my adjacent. That's my other adjacent, and that means that's my opposite because I picked angle x, right? So parentheses, super important. You got to use parentheses, because your calculator will get messed up if you don't. So let's see what the formula says. Slide this underneath here so you can see it, okay? So the formula says, all right. Slide over, okay. We're going to say adjacent, which is 20 squared, plus the other adjacent squared, so plus 21 squared, minus the opposite squared, which is minus my 18 squared, parentheses, see the parentheses, divided by parentheses, see the parentheses, have to have the entire bottom, 2 divided by the entire top, times, 2's in the front, times the adjacent, which is 20, times the adjacent, which is 21, okay? And that will give me a decimal. It will. Give me a decimal because I'm looking for an angle, because I have to cosine inverse that, so I'll just do that. I'll go parentheses, have to have parentheses, and I'll go 20 squared plus 21 squared minus 18 squared, parentheses, by parentheses, 2 times 20 times 21, and I get a decimal, expected that, but then I want to do the cosine inverse, right? Check it out, cosine inverse of that answer, so I'm going to go cosine inverse of that answer, and you got an answer about 52. So if this angle is about 52 degrees, then, and I'll let you finish this up, you have a couple of choices. To get this angle, you could use a law of sines, because now you do have a pair of opposites, or you could use a law of cosines again, but it would change your adjacents. Either way you want to do it. You could either use a law of cosine or law of sines, because you have opposites now, or you could use a law of cosines again, like you just did here. Okay. Now area. Okay, same thing. Number 6. You got a pair of opposites. So if you have a pair of opposites, boy, that one's just like number 3. Oh well. 6 and 3 are very similar. Okay, and you guys can do it. 6 is just like 3. 6 is just like 3. Okay. All right. Turn the page and let's see what I have for the second. Okay. Number 7. Okay. A regular pentagon with side lengths of 22. Okay. 22, 22, 22, 22, and 22. Okay, so here's my pentagon. If I want to find the radius of the circle and the area of the pentagon, let's take a look at some triangles. Okay. There we go. There's another triangle, and another triangle, and another triangle. Okay. Let's look at this angle here, theta. I know in a circle there's 360 degrees in a circle, but I'm going to divide that into 1, 2, 3, 4, 5 angles, and I get 72 degrees for each of these angles. 72, 72, 72, 72, 72, 72. Okay. Now, I'm running out of room, so I'll probably have to do this on a separate sheet of paper, but I can do that. It doesn't bother me. Do that on a separate sheet of paper. So let me grab a piece of paper. So let's take a look at one of these triangles, okay? 72 degrees, and I know that's 22, and I know these two sides are equal, right? X and X, right? In a triangle, this is equilateral. I'm sorry, this is an isosceles. 180 degrees minus 72. Let's see what that's going to be. 180 minus 72. I get 108. But let's divide that between these two. So I get 54 degrees. And I get 54 degrees. Okay, so let's check it out. If I want to find x, or the radius, let's just call it r. What the heck? Let's call it r. Doesn't even matter. R for radius. Okay, r and r. How about a pair of opposites? Well, I've got opposite, 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 right? So if I have a pair of opposites, I need to find a side. I'm going to use a lot of sines. So let's set up r over the sine of 54 equals 22 over the sine of 72. Okay, so it's side over the sine of its opposite angle equals side over the sine of its opposite angle. Okay, so we'll multiply it by the sine of 54. R equals 22 times the sine of 54 over the sine of 72. And that should give me the radius of the circle, okay? Let's do that real quickly on my calculator, okay? Clear 22 times the sine of 54. Close parentheses and divide that by the sine of 72. And I get an answer of about 18.7. Okay, so the radius of this thing is 18.7. So I know this side's 18.7, and this side now is 18.7, right? Now, if I want to find the area formula, I got the area formula right here, okay? So area formula, right there, it's going to be, area is going to equal 1/2 the adjacent. So if that's my 72, then my adjacent is my 18.7 times my other adjacent, which is also 18.7, times the sine of my angle, the sine of 72. Okay, so I'm just going to use my calculator. Okay, I'm all plugged into my formula. So I'm just going to go 0.5 because that's 1/2 times 18.7 times another 18.7 times the sine of 72. I get an answer of 166.3. And that's in terms, I guess, of centimeters squared because we're talking about area. Okay? That's not too bad. Hopefully you can do that tomorrow. Now, 8, a little bit harder. And let me go through it slowly, okay? Here's our navigation one. So, bearing at north, 42 degrees east, and south, 18 degrees east. So, I don't know, maybe I'll put port down here. Wait, here's my port. And I'm going to draw my picture. So I put my compass in. This just helps me if I put my compass in. North, east, south, west. I have a protractor. You guys might not, but I'm going to face north. I'm going to face north. Zero it out at north. And then rotate 42 degrees towards the east. Okay, I want to go that direction. So, and I need this to be 9. Okay, so I think I have a 9 on here. It's a pretty short ruler. Okay, 9 is right there. There's my 9 knots. Ship A, 9 knots, and this is 42 degrees. Okay, so I just drew it. Drew my compass rose. Use my ruler. 9 centimeters for the speed. And 42 degrees. Okay, ship B. Ship B is going to look south. Okay, ship B is going to look south. And rotate 18 degrees towards the east. South, 18 degrees. There's ship B. And 7. Okay, see if I can draw that in there. Yeah, okay, there we go. It's going to barely fit, but it does fit. Okay, there is ship B. 7, and then this angle is 18 degrees. Alright, here we go. Let's find this angle. That angle, I can figure out what these are as far as 90 degrees. Let's go 90 minus 42. That's 48 degrees for that angle. Let's go 90 minus 18 degrees. Should be 72, I assume. And then the entire angle is just 48 plus 72. I get an answer of 120 degrees. Okay? So that angle is 120 degrees. I need to know that. Now, the distance between them has got to be this distance here. Draw that in. Draw that in. Okay, here's the distance. We call it D. All right. Now, we're going to go for a 4-hour trip. I think it says 4 hours up here. I'm going to go for 4 hours. Same direction. So instead of redrawing the triangle bigger, I'll just multiply this by 4. Okay? So 36 is the side. Multiply this by 4, and I get 28. Okay? All right, let's see what I have. I have a side, angle, and a side. I got a side, angle, side. I don't have any opposites. So side, angle, side. I'm using a lot of cosines, right? I'm going to use this one. So I'm going to set it up as my opposite squared, which is d squared, is equal to my adjacent squared. I'm just going to go ahead and follow this. Slide this. Can you see it there? Yeah, perfect. Adjacent squared, which is 36 squared minus, oh, plus, my bad, plus my other adjacent squared, which is 28 squared, minus 2 times my adjacent, which is my 36, times my other adjacent, which is 28, times the cosine of my angle, or cosine of 120. Okay, I'm just going to use my calculator to get that answer. So clear, I'm going to go with 36 squared plus 28 squared minus 2 times 36 times 28 times the cosine of 120, okay? And I get this answer, but I'm going to take the square root of that, all right? So I got d squared equals 3088. Square root, take the square root of that answer. And I get about 55.6, I guess. Round up to 55.57. How about 6? Okay, there you go. And that's the answer for how far apart they are in terms of nautical miles. Knots, okay? Now, here's the extra. Okay, the extra looks like this. If ship A is disabled, what bearing must ship B take to rescue ship A? So ship B is hanging around down here, and he's got to look at his compass to figure out which direction to take. So he looks at his compass. Alright, and his compass points north, right? His compass points north. Alright. And we know a couple of things, that the angle we want to find is this angle here. We're going to call that theta. That's the angle I want to find right in there, okay? Now, so that's the angle I want. It's right there. What I do know is a couple of things. I knew, see if I look at this little z, I know this angle, see the z? This angle has to be 18. And if I find all of angle B, right, angle B is the whole thing. If I take away 18, I'll have my angle. Okay, so let's do it. So to find angle B, I've got my opposites, right? My opposites, let's take the sine of B, the whole angle, over its opposite side, which is 36, equals the sine of 120, over its opposite side, which is the 55.6. Okay, and so then what I'm going to do is multiply up 36, use my calculator, 36 times the sine of 120, parentheses, close parentheses, divided by 55.6, and of course I need to take the sine inverse of that, because a lot of sines, sine inverse of that answer. Okay, so I get a 34.1 degree angle, okay? We can say 34. Angle B is about 34 degrees. Now, if angle B is 34, then theta is going to be 34 degrees, because it has all of angle, minus the 18 is going to be my bearing, and 34 minus 18, I get an answer of 16 degrees. So I'd go north 16 degrees towards the east. There's my bearing. I like that. Okay, that's all I have. Test Thursday for first period. Test is going to be on Friday for fourth period. Good luck, everybody. Get this done, please. Stop.